So, I might as well be the first person to do this. How many of you are Ruby programmers? How about Python programmers? JavaScript programmers? And how about Clojure? A few people. Cool. So I think I may have a topic which might interest you no matter what your language background is. Happy to open the discussion today with that. And that topic is wormholes. Those great trolls of time and space. Because when I was preparing this talk, I was kind of thinking I'm approaching this from a Clojure perspective, where immutability is the thing, immutable data structures, but I think I should a little bit remind myself why it's actually something worth discussing, even in other languages than Clojure. And the thing it boils down to me is wormholes, and I'll explain what I mean by that. What I mean is, when we make software, there are really two kinds of perspectives we can look at that. One is that we architect and design our programs in a way that where there are different components with well-defined interfaces, decoupled interfaces, with a kind of good orthogonality between the components. But often there's also this other reality where there are these invisible connections between components where there shouldn't be any, and this is because of mutable state. When there are two components looking at the same mutable data structure, the other can influence the other without much control, so we can bypass the normal structure of the system. And I think this is easiest to think about when we look at global variables, because we've all been taught they are a bad idea, because they kill modularity. When there's a global variable anyone can access, all bets are off about what's going to happen, because anyone can influence anyone. But what I think, though, is that the worst part about global variables is not that they are global, because immutable global variables are quite okay, because they're constants, basically. We use them all the time. What is the problem with global variables is also true of non-global variables, I think, and that's that they are mutable. When I hand you a mutable data structure, we now have this wormhole between us where I can change it without letting you know about that. And that's how the program becomes modeled with these connections that make it more complex. So that's why I think this is a topic worth discussing. And what I'm going to do today is kind of raise these languages we talk about in this conference against each other by looking at how well do they support this kind of programming where we try to eliminate the wormholes. Because although it's our responsibility to construct our programs in a way that eliminates wormholes, there's also a lot the language and the libraries can do to help us make it easy or make it more difficult. So this is a game with 3 levels, and let's get right into it. Level 1 is called primitives, and as in many games, it's actually quite an easy level. Here's a primitive. This is 42. It's a number. There are also other numbers, but this is a good example. And numbers are, in all of these languages, in most languages, immutable data structures. You can't change a number. It's a value. You only do operations on it, which produces another number. Arithmetic methods, whatever. We can't even really think about numbers as mutable data structures because it's just never been like that for us. And so that's a boring first level. Everyone gets full points because it was so easy. Let's see if level 2 will make it a little bit more interesting. Strings are slightly more interesting than primitives such as numbers or booleans because you can think of them as compound data structures. They are really collections of the individual characters or character codes within, so you get the discussion about, can I actually change the string? Can I remove a character? Can I put something in the middle and mutate it that way? So let's see how the languages stack up with this. JavaScript strings are actually immutable. So you can do all kinds of things with JavaScript strings, but you can never change a string once you have made it. You can only return new versions of the string. So JavaScript got this one right. Python, same thing, immutable strings. You can do stuff with strings, but always producing new values, never changing a string. Clojure, not surprisingly, also immutable strings. They are actually Java strings underneath, and Java has immutable strings. So this is still kind of boring, I think, because everything is doing so well. Luckily, we can often trust Ruby to make things interesting. Ruby strings are slightly different. They do have this nice immutable interface where just like with these other languages, you can produce new values from strings. But there is a dark side to Ruby strings. You can actually go and change it in place. You can add stuff to a string, you can remove stuff from it. All bets are off. So here's our first mutable data structure, Ruby strings. And right away that opens up some interesting fun things we can do. For example, we can make a key and a value, make a hash out of that. And of course, when we access the hash with the key, we get the value because that's the key. But when we change the key, it stops working because now the value of the key has changed. But some other string which has the same value as our key had before does work. So that's because the hash uses the keys by value, not by object identity, as it should. But this kind of makes it unclear what's the key and what's not, because when things can change, the same friggin' object that we actually just put in the hash is no longer the key. Something else is. Another fun thing we can do is introduce a wormhole, which is maybe I've given you that hash I just made, you stored it for future use, but after that I just go and change it around. The string inside the hash now has a completely different value than what it was when I gave it to you. So using this wormhole, I've gone into the data structure that you have and changed it around, and you have no idea until you try to use it. That's the problem I'm talking about. So there are things you can do in Ruby to fix this. You can freeze a string like you can any object in Ruby, which means that after you've done that, any mutation you try to do will raise an exception. So that's handy in some situations. And of course, particularly with hashes, we tend to use symbols instead of strings as keys. And there are many reasons for that, and one of them is that they are in fact immutable. You cannot go and change a symbol around. It's once you've made it, that's what it is. So in Ruby, you can always work around things, but I still would say that it loses this round. Everyone else got this right, except Ruby. And of course, it's a value judgment whether you like it or not. Guido, the creator of Python, called Ruby strings an abomination, so that's one opinion. So the lead is still kind of even. I guess most people know where this is going, but let's go through it anyway. Level 3, collections, which is by far the most tough round, the final round, things like arrays and dictionaries and lists and hashes. How do they work in these languages? Let's start with the easy one. Clojure has collections like vectors, lists, hash maps, sets, all of them completely immutable. So whatever you do, you add stuff to a vector, you change things around, you always get the new version as a return value. You can never change a Clojure collection. So that works with vectors. It works with hash maps. When you associate a value in a hash map, you get a new version of the hash map, and the original stays the same. Everything works like this in Clojure, which is great, but also makes it not so interesting for our discussion because we can't mess with it. Let's look at Ruby. Ruby arrays have a very nice immutable functional interface to them where you can call these higher order operations on them, produce new values, which is nice, but it's just a facade really. They're just plain old arrays underneath and you can just go bash them in place. So no guarantees whatsoever about immutability there. With Ruby hashes also, same thing, you can use them in an immutable way by using these operations that don't mutate them. But they are not immutable. You can do the same stuff in place just as well. Or some other person working within your program might do that. One thing you can do with arrays, just like with strings, is, as well as hashes, is to freeze them, which means you can no longer change them. But the thing to know about that is that that's a shallow operation. So even if you have a frozen array, if there's something inside that array which is mutable, you can still do that because there's no guarantees. So even with freezing an array, you can't know if it's immutable or not because there might be stuff in it which is not immutable. As I did here for the mutable string inside the frozen array. There are libraries to fix that as well. There's one gem called ice9 which has a method called deep freeze, which actually goes and recursively freezes everything inside a data structure so that you kind of have a guarantee of a frozen, immutable thing. Might come in handy sometimes. One other library in Ruby I would like to point out is one called Hamster, which is a pure Ruby implementation of the kind of immutable, persistent data structures that Clojure has. So it gives you things you can use instead of the built-in arrays and hashes and sets that are completely immutable. And you can use them as you would Clojure data structures, which is kind of nice. So it has vectors, it has hashes, things like that. So particularly if you have a lot of data and you need to work with it efficiently, but still with the safety guarantees of immutable data, you can use Hamster. What you lose, though, is the ability to use the syntactic niceness of literal arrays and hashes, because you always have to call these methods instead to produce these data structures. So it's far from perfect, but it's a nice library. So that's it for Ruby. Let's look at Python. Python has lists, like Ruby has arrays, and just like Ruby's arrays, they can be used in an immutable way with list comprehensions and lambda expressions and everything like that. So it's quite a nice way to work with lists. You have everything you need, really. But also, just like Ruby, it's not immutable. You can still go and change it in place. So very similar Ruby and Python in this regard. Python does have another sequential type, which is the tuple. And it in fact is immutable, so you can't go change one when you've created it. There is no kind of mutation operations on that. And I'm not really a Python programmer, so I'm not aware of all the subtleties between the two types, but seems to me it's a good idea to prefer tuples when they're otherwise appropriate because of this issue that they are in fact immutable. Python dictionaries, well, you probably guess by now how it works. You can use them in an immutable way with comprehensions, with other kinds of expressions, but that's just one way you can use them. You can still do imperative style with them and change them in place. There is a bonus point that Python gets, which is that dictionaries don't let you use mutable things as keys. So you can't do what we did with Ruby and mess with the key, because it doesn't let you put anything as the key that can be mutated. So you can't use an array, or actually a list as a key where you can use a tuple. So that's a nice thing, I think, about Python dictionaries. Finally, JavaScript collections. So JavaScript has the array type, and modern JavaScript environments do have a really nice way of working with them immutably with MapReduce and filter. And even old JavaScript environments can be patched with libraries. But it's still an array, just an array. And the kind of default way you still use them is in an imperative style. Objects, the story here is not that great. JavaScript doesn't give you much in terms of working with objects, treating them as immutable objects. So what you do immediately, usually, if you want to do that, is pull in some library like underscore, which lets you do things like that. Because JavaScript objects really are treated as totally immutable things, where you add stuff and remove stuff in place. In modern JavaScript environments, there's also a freeze function in the object, which, just like Ruby's freeze, makes changes to that object impossible. And how it behaves is shown here. You can assign something to the object, and it looks like it works, but it actually doesn't. It doesn't change anything. Actually, the way it behaves depends a little bit on the execution context. If you use the strict mode in JavaScript, trying to mutate a frozen object throws an exception. But in non-strict environments like mine here, it just ignores it. But in any case, it doesn't actually mutate. Finally, in JavaScript, I would like to mention the Mori library, which is a really cool library. It's basically gives you the Clojure persistent immutable data structures for use in JavaScript. Because as you may know, Clojure now compiles to JavaScript as well, and David Nolan has done the work of extracting the data structures from Clojure and putting a nice JavaScript interface on them and put it all in one file, which you can include in your browser application or Node application, and use Clojure data structures in your JavaScript programs, which is nice to do. So you can do vectors, you can do hash maps instead of your JavaScript arrays and objects. So it has the same drawbacks as hamster in Ruby. Basically, you lose the kind of syntactic and other convenience of the built-in data structures because you're using these other types. But if you need that kind of stuff, it's really nice to have because they are battle-tested, efficient data structures. That concludes the race for now. By my totally arbitrary scoring scheme, Clojure wins this, which was probably no surprise because it was set up that way. Python comes in second because it's kind of a mixed bag, but it does have a few nice things it does with the tuples and things like that, making it, in many cases, easier to use in an immutable way. JavaScript I put in third because even though it doesn't give you much built in, it's really easy to use immutable data structures. And Ruby I penalized for the string thing, which is weird. And also with Ruby, that it's just, I love Ruby, but you know, it's pulling me down. You can do anything with Ruby, you know, you can redefine what 2 + 2 means, but you know, don't. So it doesn't mean that one language is better than the other. It just means that this is what I think these languages do for us in terms of making it easy to work with immutable data structures. But of course, in the end, it's up to us to do the right thing and make programs that don't ship with too many wormholes, or if they do, that we know where they are and we know what they're doing. Thanks. So we have a few minutes for discussion. So if you have any questions or comments, I would love to hear them. Yeah. So if I repeat the question, the concern was about Mori and the kind of performance trade-offs you make with that. You get the immutability, but what's the cost? Well, with immutability, there is always a little bit of performance cost because you can't change things in place. You have to produce new things, and there's a bit more work with that. And it puts often a lot of strain on the garbage collector, if there is one, because there's a lot of garbage produced. What Mori and Clojure data structures do, though, because of the persistence stuff in there, it's actually not that costly to use them. There is a trade-off in performance to arrays and objects, but it's not as bad as just naive copying of data structures because of the structural sharing Clojure uses. In the persistent data structures, so for example, if you add one thing to a vector, it's mostly internally sharing the structure between the old vector, just with the new thing added to it. So it does slightly more work, but not that much. If you're really struggling with performance, you're going to have to go with native arrays, but in most cases, I don't think this is going to be the bottleneck, because in browsers, for example, the DOM is always going to be more problematic in most cases.
You mentioned garbage collection,
yeah.
And I know that Clojure now compiles to JavaScript, but the garbage collection strategy and the amount of garbage that can be collected in unit time is very different for the JVM and for JavaScript virtual machine. So how does Clojure script deal with that?
Clojure script basically doesn't deal with it anyway. It just lets the native garbage collector do whatever it does. And of course, there are wild differences in the performance of different browsers and VMs. So yeah, it just lets the native GC do its thing. And yeah, I should say I haven't used persistent data structures in anger in browsers yet. So all of these answers I give come with the caveat that this is a guessing from my part at this point. But I have a feeling that like modern browsers, at least on laptops or desktops, are going to do just fine.
I was wondering whether Clojure enforced the structural sharing that you mentioned in the runtime level, like a language like Haskell would do, or whether you have to actually keep that in mind when trying to implement an immutable data structure.
Sorry, can you repeat that?
Let's assume you want to implement an immutable data structure.
Yes.
in Clojure.
Okay.
Is the default way that the runtime implements objects. So you mentioned structural sharing, for example.
Yes.
Does it allow you to do mutable structures, so you could shoot yourself in the foot when doing that?
You mean when implementing your own like object structures, or the structural sharing? If you mean if it's safe or not, is or
test. I was more asking in the direction compared to a language like Haskell, where everything is basically copied and you get structural sharing on the runtime level, more or less.
Yeah.
Is that the case in Clojure as well, or especially if you're implementing something yourself, would you have to keep that in mind if you want?
Right. Yeah. Well, you do have to keep it in mind in Clojure, but the way you kind of work with the data structures is that it just happens. Whatever operations Clojure gives you and the own abstractions you make out of them are going to use the structural sharing if it makes sense or not. But the difference to Haskell really is that Clojure is not pure and it's dynamically typed, so it's not completely guaranteed by anything like a type system that what you have is actually immutable, and whether it's persistent or anything, it's just an abstraction, a sequential thing, which might just as well be a mutable Java array. So there are things to look out for in Clojure. But from my experience, as long as you stick to the native data structures and make your abstractions out of them and don't step out of that world, it doesn't shoot you in the foot. That hasn't happened for me. Any other questions?
Okay.
Guess not.
Thank you, Tero.
Thank you.